we are going to start off, well, good things. Do we have any good things?
I got a new phone.
Got a new phone?
Yeah.
What kind of phone did you get? I got a new phone too. Oh, okay, so you paid big bucks for your phone. Okay, I can't pay it.
It was like a trade-in, so I got it like cheaper.
Oh, well, that's good. Do you like it? I'm not an iPhone person. I probably should be.
I like it. It's just really big.
Yeah, well, when you break those really big phones, they are really expensive to fix. All right, so our agenda today, we're just going to we're going to do our ACT prep because you 11th graders have ACT at school coming up March 29th. So if you hadn't marked that on your schedule, make sure you mark it on your schedule. That way, the night before, you are rested, you eat breakfast that morning. You guys, get prepared for that test because it is a long endurance test. Okay? And you guys, you'll have a short bathroom break in between, but you guys aren't going to be able to eat. You guys aren't going to be able to do all that. You can't take your phones in there. You can't take your book bags in there. So you have literally nothing in that room with you. Okay? I know it sucks, but it'll be okay. I want you to do the best that you can because this one that you're taking is free. Okay, the school's paying for you to take this. So try to do your best on this test. So that way, maybe if you get a higher score, maybe you don't have to do this all over again. Okay? So I do know that you guys will be missing that day of class, which, to be honest, I don't, that's the week after spring break. Okay? I don't know what day that falls on. But anyways, but that's the week after spring break, that 29th, whatever that day falls on. All right, so otherwise, we are going to do our ACT question, our do now. We'll go over it so you have the right answers. And then we're going to do a little bit of reading in class. And then we will start review. And then I will introduce you to the new concept that we are going into. Okay? As you know, your ACT prep is timed. I'm going to give you 8 minutes in order for you to finish and complete this. Don't turn it over till I tell you. Okay? All right. So your 8 minutes starts now. Go ahead and turn your paper over and get started. Make sure you put your name and your block on there. right, you have about 5.5 minutes. You have 3.5 minutes left. Have about 1.5 minutes. Don't rush, please read it. Have about 30 seconds left. put your pencils down and grab the red pen that I set on your desk. And I just want you to actually circle the right answers. If you had it wrong, you don't have to put an X on it. Just circle the right one so you know which one it is. All right, so number 16. This was a math question. You could use a calculator. ACT does allow you to use the calculator. So, what was our answer for number 16? Anyone want to take a guess? C? Anybody else? Your correct answer is C. So if you didn't have it, go ahead and mark it now. All right. Let's go to question number 17. 17 was more along the punctuation, the English type, okay? So what can we say for number 17? What did you get? Come on. Jaden, what'd you get? You got C. Anyone else? Something different. Kalina, what'd you get? C. Okay, so actually the correct answer on that one is A. So there actually would be no change in that sentence, okay? All right. All right, so number 18. Who wants me to tell you what she thought? What do you think it was? After reading, after looking at the graph, now this is more science because most of your science questions on the ACT, if you do not already know, are graph questions. So you guys are going to have to make sure that you know how to read a graph. We went over graphs, if you can remember at the beginning of the year, we went over graphs. And so that's just to help you along the way. So when you see these graphs, you're actually able to read them. All right. So for number 18, what did we get? A. I have anything different from A? No? Okay, so actually the correct answer is A. The number of sunspots is highest when the sun is near its maximum brightness. Okay? So the maximum brightness was that, the wavelength of brightness was that solid line. Okay? And then the number of sunspots was the dotted line. Okay? All right, last one, number 19. This was another English question based on, pretty much punctuation. So what could we do? Beginning of the sentence, what could we do than what it showed? Come on, take a guess. You picked C, you said C? Okay, well, we could, I can see where you could get that at, but if we're getting right to the point, then we could actually take out the first word completely, couldn't we? And just start the sentence at the, right? I know we like to add those little words in because if we're trying to hit a certain number of words, but sometimes it doesn't really make sense for us to do that. Okay? All right. So you should have that. I still want you to turn it in so I can give you credit for it. So go ahead and put that in the basket. Make sure your name and block today's date, which is March 7th. Good Lord, it's going too fast. And then we will go ahead, just take you a walk, put that in the basket, and then we'll go ahead and get started on the next thing.
I did bad on that.
You did bad? Well,
I missed one, so that's fine.
you just gotta take your time, and even though it's time, the ACT marks what you've completed. So
on the last one, I got sick because I was like, all of these could work, but there is extra words, but I still went with as the. I forgot about being concise.
So, and some of them, like, I'm not the best English person when it comes to all those punctuation and grammar and all that stuff. I do try, but that's also, we don't, I think we miss that skill almost so much because we have technology. And so we're all, you can highlight it and, or it'll underline or something like that. And I think that's where we get a lot of our problems from. But anyways, all right. So I started getting these magazines in. And you have one on your desk. It's called Science World. I wanted to read something. They want us to put that, reading into our work as far as our class time. So I want you guys to read, and they're not very big articles, so it's not going to take you a whole lot of time. Okay? But I want you to read 2 and 3 and the top of page 4. And I'm going to give you a couple minutes to read, and then we'll kind of discuss what you read. Okay? So 2 and 3 and the top of page 4. Okay, you'll see on page 4 where it kind of splits the page in half. Need a few more minutes? Go ahead. It's fine, no biggie. Is it cold? I don't know. I have 2 shirts on this shirt. All right, are we all done? Okay, so let's discuss the first story. Okay, I love Galapagos Islands. I love it. I'm gonna eventually take a trip there sometime in my life. Okay, if it's to do research, whatever. I don't even care. They have a lot of different species on Galapagos Island because it's like untouched by man. You can go there, observe, do all that, but this is also where they have the Komodo dragons. If you've ever seen those are like really, really huge lizards. Huge lizards. Okay. They also have the tortoises. They have a lot of species on that island, which It's great because it's untouched by man. Now, when they go over there, they usually just do like they're observing, they're doing field work. They take surveys. They might tag animals just to see what they do. This particular animal is a pink land iguana. As you can see, the iguana is a pretty good size, but it remains that particular color over there. Now, it's an endangered species, and it talks about that because there's only 300 to 350. Okay? So, and they're living in the wild. They're not in a zoo. They're not anywhere like that. They're all right there together. But they go over there, they take measurements, they see how fast they grow, they get to know all of this knowledge about them, and I think that that's really cool. So the next story, which is on page 4, the top of page 4, which is ducks in a row, okay? Now, I'm going to tell you a personal story before I get to the article. Okay, my personal story is this. Y'all know I have a daughter. And when she was little, we happened to go to Atwoods. No, was it Atwoods that we went? Either one. It was one of those, okay? And she wanted ducks. Okay, and I thought, oh, be cute. We'll get one. Well, you can't buy just one duck. You have to buy 6. So I ended up with 6 ducks. She had them in my guest bathroom. You know, they were chilling in there because they were really, really small. And they were really cute. You know, and that whole thing that they really waddle. But anyways, so they were really cute, and she had them in there, and we would transfer them to a container because they were still small. But ducks grow really fast. If you don't know that already, which I learned how fast they really do grow. It's not like a doggy, but they grow really, really fast. And so, they grew to the point where they wanted to get out. They wanted to roam, okay? And might I add you, this is still in my house. So I said, okay, well, you know, let's give them some water time. So we took them in the guest bathroom and put them in the bathtub. We ran some water, and they would get off, and they would dive back in. And it was really cute, really, really cute. Well, I was like, okay, so I left Aria and said, I'm going to let you play with your ducks for a little bit, and I'm gonna go in the kitchen. Well, I didn't think nothing about it. Well, of course, Aria didn't either. So Aria leaves the door open, and she gets up, and she's like, Mama, I'm thirsty. So she comes, and all you see is all of these ducks behind her. They're like, doo, 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 down the hallway. They're wet, and they're coming, and they are following her wherever she goes. And so I was like, how funny is that, you know? And they literally, from that point on, they followed her everywhere. Everywhere. And I didn't know that they attached so well, but they were so attached to her. Now, the bad part about that is because they got so big, of course, we had to transfer them outside, which I have a pond, which is great. We made them a little thingy, which was great. My dog at the time was a Mastiff that stood this tall, and she thought they were a snack. So she took them out one by one, which was the bad story about that. But anyways, I thought this article was really cool because I don't know if you've ever been to a park or anywhere like that where you've actually seen this happen. Well, yeah. But, I mean, she even had to get in the water with them so they would go in the water. Like, it was bad, y'all. But anyways. So the story is talking about, it's breaking down the whole physics of this force and motion, which most of you have had physical science already, so you got to know how this works. But I never knew there was, you know, I guess when you see it, you think, oh, that's just nature, but you never think that there is a, you know, topic to it, I guess. I don't know. But you never think that there's more to it when there's so much more to science than just science. And then we wonder, why do we know this? Why do we got to know this? Well, this is one of those things. It actually happens. Okay? It actually, you see it in motion all the time, but you don't think about it being force in motion. You think, oh, it's just cute because the baby is following the mom. But the mom is leading the pathway, and she is like literally like kind of being like the braking force so their little legs can swim. Okay? So I thought that story was really cool. We're gonna try to incorporate this pretty much, all these articles. That way we can get, we get some news in, we can get some science in, and hopefully it starts helping you connect what you're learning to different things, okay? All right, so you can go ahead and put that away. You just leave it on the desk. All right.
Now I want ducks.
Now you want ducks? Yeah.
But then I
See?
want to get big. So
They get big rather fast, which is really crazy, but it is what it is. But they're fun. They're fun to look at and fun to watch. They really are. If I had room, we'd have some ducks in here. We have ducks, and we put them in the. There's a big old fish tank back there, so we put them in the fish tank and let them roam. But then, when we're not here, Jesus help us. Yeah, the maintenance probably would not like me too much if I had ducks, and they would have to clean up that mess. Just saying. Okay. All right. So we're gonna go through. The first part of this is review over what the things that we've already went over, the things that we've already talked about. But we're just going to hone in on that because on Wednesday, I'm going to give you guys an overall quiz about the Lewis dot structure, okay? And the last part of the Lewis dot structure that we did where you had to where it was bonding molecules together or two elements together, and you had to draw like the line if they were sharing the molecule or the electron, but if they were sharing. But now we're going to break that down, and the reason I'm starting with review is because the review is going to lead you up to that point, because everything that you've learned you can't forget. You've got to hold on to it so that way we can continue to go forward. Okay? So you want to get your notebooks out because there are going to be a couple of things that you are going to need to know. There are going to be a couple of things that you are going to need to go ahead and write down. There are a couple of added vocabulary words that you guys do not have. And so you are going to need that in order to keep up. And we'll go through the vocabulary, something you'll get throughout the PowerPoint. So I want you to make sure that you have that, that way you can study. Okay? So the chemical bonding, we're going to go through two properties of bonding, which is covalent and ionic bonding. Okay, so to start off, these are your terms, okay? The right-hand side over here are the ones that are going to be new to you. So you want to go ahead and write those down into your notebook. If you write them down now, periodically as we go through, you will have definitions on the PowerPoint that will actually help you actually get the definition for those words, and you won't have to look them up on your own, okay? Now, we may not get all the way through the PowerPoint today, but I will stop and then we'll pick up exactly where we left off on Wednesday. Yeah. Give you another minute or so, that way you can write these down. guys ready? All right, so reviewing back to the I can statement, I can draw Lewis dot structures from atoms to simple molecules. This is where your quiz on Wednesday will come in. We will go through that and look, now the notes that you took before actually should have most of this on here. I'll go ahead and play this video.
So I've got my essay written, and I've been working on it for about a
short
week.
video.
So now I'm going to show you.
It's not long. Well, this one's long.
We're going to
We
talk
won't
a
be long
lot
for long.
about electrons. First, we're going to start out looking at an atom and looking at the spaces in an atom where electrons can live. Then we'll learn about the most important type of electrons in an atom. These are called the valence electrons. We'll learn how you can figure out how many valence electrons an atom has by looking at where that atom is on the periodic table. And finally, we'll look at how you can take an atom.
So let me stop him there. Okay, so the one thing is that, like I said, this is review, which most of you we already know how to file valence electrons, correct? Yay or no? Okay, so I'm gonna move this so everybody can see it, okay? All right, so this is where we are, okay? Stand. Thank you so much. Stand. Yeah, of course not. You see? Yes. Okay. All right. So we know looking at a periodic table, which you should have your own periodic table, and you should have it already listed for you. Because how do we know the valence electrons? What do we look at?
The group number.
The group. And the group number is where?
The top.
The top. So we're going across the top. Okay. And those make our columns, correct? Okay. So we already know that in group 1, how many valence electrons do we have?
1,
Group 2.
2,
Okay, then we skip over here. 3.
4, 5, 6, 7, 8, except helium.
Except helium, okay? And helium has
2.
2, okay? So, really this first part about this video you already know. The only thing that you're looking for is the connection between
Atom.
how they connect.
And draw one of these electron dot diagrams for it that shows how many electrons it has. So let's get started. Okay, so check out this diagram of an atom I have here. In the middle is the nucleus with protons and neutrons. And now look at all of these little circles. Each one of these circles represents a spot that could hold one electron. You can think of these as like parking spots for electrons, or like theater seats for electrons. And these spots for electrons are organized into these circles. These circles are called energy levels or shells. You can think of these energy levels or shells sort of like they show the path
Now,
that
I'm
the
going to skip through
electrons
this
would
because most of
take
you, we
as
already know
they're
this, okay?
spinning
We've
around
already
the
done
nucleus.
this.
One electron
So I'm
hydrogen.
going to skip up here.
So we're going to fill that in. That was really easy, right? So we got this first energy level in hydrogen. One of the spots is still empty, and one of the spots is full. Okay, let's move down here to lithium. Now, if we look up lithium on the periodic table, we're going to see this 3, which means that every
Now this
lithium
is
atom
just
has
drawing
3
those,
protons in it. But if that
this is drawing those in the Bohr models, which we've already learned that, correct? Everybody good on drawing a Bohr model for your elements? Yes, okay? All right. We're going to keep going. Okay? All right, so also in this statement, you learned that the valence electrons are on the outermost electrons of the atom. They are on that outer rim of that Bohr model. The group number we've already stated is what gives us our valence electrons numbers, okay? We know, do you remember the octet rule? Okay, and the octet rule states that how many valence electrons can we have?
8.
8. So like octopus, 8 arms. Okay, so we can only have 8 electrons on that outer rim. Okay, and even when you draw a Lewis dot model, how many electrons are allowed around it? 2, 4, 6,
Yeah, 8.
8. Okay, so helium, of course, we've already said there's an exception to this rule. So we know it is full because it has the 2 electrons, and that's because it has only 1 orbital or shell. Okay? All right. If you do not have this marked already on your periodic table, or if you need a new periodic table so that way you have this written down, I need you to make sure that you have these numbers because those are your valence electrons in that group. Okay? So if you can't remember that based on the group number, I need you to make sure that you have this written on your periodic table. Okay? This is kind of that study thing for you. This gives you that visual that you might need in order to study because words, start sounding the same after a while. Okay? So I'll give you, about 10, 15 seconds to get that written down if you don't already have it. And everybody has a periodic table, correct? Still? Yay, thank you. So what I do is right above that group, I, circle it, put the numbers, so that way I know that that's it. That's how I was doing that, okay? All right. So Lewis dot structures. We now know that the Lewis dot structure only shows valence electrons. We know that it's displayed with the symbol and dots. So we already know that. Maximum around it is 8. Okay? This is steps. These steps should already be in your notebook because, like I said, this is review. So practicing, if you want to practice those, that would be great. But let's do it together really quickly on the board. If I'm drawing a Lewis dot structure for Na, what does it look like? What do I do? How many electrons do I have? I only have 1, so I just put the dot here. What about carbon?
You got 4, so 1 around each side.
Okay, so I have 4, 1 around each side. What's my next one? Sulfur.
That's 6, so 2, 2, and 2.
Okay, remember that invisible square that's around it that I'm lining them up on. And then Cl.
Yeah, 2, 2, 2, and 1.
So I have a total of how many valence electrons for this one?
7.
7, okay? So that's how those would look as examples, okay? And it sounds like you guys are pretty good at that. This is an example of it on a periodic table. I didn't give you all this because I did want you to learn it by the group number, but that's what it would look like if we had a periodic table just with the Lewis dot on there, okay? Everybody see that? Those red dots are the valence electrons, all right?
So does the placement, make any difference? Because on there, we have sulfur that has 2, 2, and then 1 on each side, and we did,
Sulfur.
yeah.
You're talking about here.
Yeah.
No, because as long as you're putting them, you remember the, the little invisible box that you're supposed to follow, as long as you have them on there, no, the placement doesn't matter. As long as you have them around there. Now you can't, some of them, some people put them all on one side. Now that does matter.
So no stacking, none of that.
So no stacking. So it should, they all should have a place. 2, 2, 2, and 2. And you fill in what you have. Okay? Any more questions? Good question, man. No? Okay, so now this is the rule that we were talking about before we got into our presentations. the atoms having 4 or less, they're either losing the electrons or they're gaining the electrons, okay? So that means they're either becoming what? Either remember the vocabulary? They sound similar.
Is it the anion and cation?
Yeah, okay, so if I lose an electron, I become positive if I lose. Don't get mixed up with those words. And I become a cation, okay? I know, it seems like it would be the other way around. I know.
If you lose, you become positive cation, and then if you gain, you become negative anion.
Yes. Okay, so this should be in your guided notes, what we did, okay? So this is not new. You shouldn't have to write this. Like I said, it's in your guided notes. And remember that we did the little graphic organizer where it had cation and it had anion, and then it told you exactly, okay, all of those. So just to read this off, atoms that have less than 4 valence electrons will lose their electrons in order to complete the octet. Okay, so remember our goal is to be stable. And to be stable, we need 8 electrons in that outer shell. Okay? Atoms that have more than 4 valence electrons will gain electrons in order to have a complete octet, which means that I'm going to take from you whatever element it is. I'm going to take from you. I'm going to get what I need, regardless of what you do. I'm going to get what I need in order to become full. Okay? All right. And the question, think about what happens when an atom loses or gains electrons. Okay? Well, we already did that pretty much. So make sure that you have those in your head. Because when it plays out and you have, for an example, you have this, okay, you have NaCl, okay, people walking down the hallway making me nervous. Anyways, all right, so your Na, how many valence electrons does Na have?
1.
It has 1. How many does chlorine have?
7.
7. Okay, so here we are. Now, what would make sense? For me to give up all 7 or for me to gain 1?
Gain 1.
Gain 1. Okay, so when I do that, draw my little arrow. This little person comes over here. Now, when Na loses, I become what? Na loses an electron, becomes a positive or negative? A positive. So then, when I rewrite this, this is positive. Okay? And then Cl gains, so it becomes what? Negative. Opposites attract. So that's why I can make, and that song gets stuck in my head, you know. But, so then it makes NaCl, which is sodium chloride, which is known as table salt. Okay? Now, you don't necessarily have to write that because it's understood, but that one you would have to write. Okay? All right. Any questions up until that point? Anything? Anything that you can think about? Not sure about? Maybe you didn't know you had a question about. Okay? Let's move on. All right, so determining charges. Now, we're not going to do this on paper. We're actually just going to do it verbally because, again, if you don't have this written on your periodic table, you will need to. All right, so the first question starts with the first column here. Okay? So my first column, I have that 1 valence electron, correct? Okay, I have that 1 valence electron. So that means I'm less than 4, which means that I'm going to give it up, correct?
Yeah.
Which is going to make me what then?
Positive.
Positive. So that means a positive 1 charge is there. Okay? Group 2. How many valence electrons do I have? 2. I'm less than 4. So I'm going to give up those 2, aren't I? So then that makes me what?
Positive.
A positive 2. Okay, so that says I gave up 2. All right? Now you can see those numbers across there. So 13, how many valence electrons do I have?
3.
3. I'm less than 4, so I'm gonna give up, correct?
Plus
So that's gonna make me a positive 3. And then 14, group 14, 4. Now this could go either way. This can go either way depending on what's being formed. So it can be a positive or negative 4. Okay? And then we still have some in 16. Did I skip 15?
Yes.
I did, didn't I? Alright, so 15. How many do we have? 5. So then I'm probably more than likely, the way they have those outlined, you're probably going to give up 3 of those, the way they have them done, okay? And that's because of your shells and the way that they are designed. And then group 16.
6 valences. We are losing 2.
So that means I'm gonna gain. So see, I gained. I'm gaining, so what's my number turning into?
Negative.
A negative, because I'm gaining it. So let's just say my switch point was 14. Okay, at this point, everything's been positive, correct? So my switch point, everything after that becomes negative number, doesn't it?
Yeah.
Because now I'm over 4. So when I'm more than 4, I'm going to gain them, correct? Okay, that's what we said earlier. So now I'm gaining these. Do I? It becomes negative when I gain, which is forming an anion. All right? Now, the only one that we don't see is group 18. Tell me why group 18?
They're neutral.
They're neutral. Why are they neutral?
Their outer shell's full.
Because their outer shell is full. They have a complete octet, correct?
They're stable.
They are stable. Okay? So, only one different there is helium, but it is stable because it only has the 1 shell. Okay? Alright, so this shows you how that goes. So, like I said, if you don't have this already marked on your periodic table, if you're that person that needs that visual, then this is what you're gonna write on top of there. So we know group 1 is a positive, group 2 is a positive, group 3 is a positive. Group 4 is that middle ground where it could go either way depending on the bond. And then we know that past that group starts going negative. Okay? I know we have in our head that when it's negative, we always lose. When it's positive, you always gain. I know. I had that in my head for the longest time, and I thought, okay, it's got to be another way. And so then I changed it to, if I take from you, then I'm stealing from you. I'm taking what you have, so that makes me a negative person. Then if I give, I'm doing a positive action. So, and that's literally how I had to remember it all the way through school. Crazy stuff.
That's what I was telling Michael the other day. I was like, you give, you're positive, you're a nice person. Now, you take.
Right. Well, and and some people I think it was Constance that was having such a hard problem with the wording. She was like, it's not supposed to be that way. Well, I get it. But anyways, all right. So let's keep moving on. All right. So I can identify types of compounds versus ions. We already have these key terms. this is what our ICANN statement is. This is what we will be working on. Okay? All right. So to start with our new vocabulary, we're going to do ionic bonds. Okay? Ionic bonds means I'm going to transfer my electrons to you. And this happens between metals and non-metals. Okay? Which you should already have compound, which if you do not, it's here. And compounds just are telling us that they are made up of two or more elements that are chemically bonded. Now that was, we've had that word several times now. Okay, ionic. Now instead of writing, which is good note behavior, instead of writing all of ionic compound, just put an ionic compound. It transfers electrons and it's made up of a metal and a non-metal. Okay.